Okay, now we're going to be learning about some additional trig identities. And I think we've already introduced this one, but if not, tangent theta is equal to sine theta over cosine theta. And you need to prove that. But before we get to that, let's just go over the other ones. So there's these Pythagorean trig identities, and this is where, especially using on the unit circle, that sine squared theta plus cosine squared theta is equal to 1. Tangent squared theta plus 1 is equal to secant squared theta. And then cotangent squared theta plus 1 is equal to cosecant squared theta. And then also one other, if I can move over there, we need to prove that sine squared theta plus cosine squared theta is equal to 1. Let's first work on this one. Prove that tangent. This is kind of the steps that you'll use because you'll be proving identities. So tangent theta is equal to sine theta over cosine theta. All right, well, sine theta is the same as opposite over hypotenuse. Cosine theta is the same as adjacent over, so I'm going to go ahead and keep putting tangent theta. Well, remember, when we have a complex fraction, we don't want that, so we have to multiply the denominator by the reciprocal. So I'm going to multiply hypotenuse over adjacent. Those cancel. But then I have to multiply in the numerator. Hypotenuse over adjacent. Those cancel. Leaving a 1, leaving a 1. Tangent theta is equal opposite times 1 is opposite over hypotenuse, adjacent times 1 is adjacent. And then for the last step, tangent is opposite over adjacent equals opposite over adjacent. Ta-da! So we proved that. Let's come over here and it shows prove that sine squared theta plus cosine squared theta is equal to 1. So I just went ahead and labeled. So here's our theta, here's the opposite side, here's the adjacent side, here's the hypotenuse. And remember, if this is just the names of legs, adjacent squared plus opposite squared is equal to hypotenuse squared. That's just a squared plus b squared is equal to c squared. That's all we did there. Here's an A, here's a B, here's a C. All right, so I want you to keep that in mind. But then let's also look. So sine squared, I'm going to turn sine into opposite over hypotenuse and cosine to adjacent over hypotenuse. And I'm going to square both of those. And notice the hypotenuse are the same denominator. So when I rewrite it, I can just put the entire fraction over hypotenuse squared. Because remember, when you square a fraction, both the numerator and the denominator get squared. Well, look at what we can substitute. Look what we know. Adjacent squared plus opposite squared is equal. So here we have adjacent squared plus opposite squared. We can substitute this, and we can write hypotenuse squared over hypotenuse squared is equal to 1. 1 is hypotenuse divided by hypotenuse squared divided by hypotenuse squared is 1. Those two check out. And I think that, oh, no, we're going to keep going on these. Okay, so we have some others that we need to do here. So now we've got cotangent squared x minus tangent squared x is equal to cosecant squared x minus secant squared x. Well, if you remember a minute ago, right up here, in fact, the trick is always, whenever you've got tangents or cotangents or secants, whoops. There we go. You're probably going to want to use a version of the Pythagorean theorem. So look at tangent squared is plus 1 is equal to secant squared. Cotangent squared plus 1 is equal to cosecant. So I'm going to come back down here. And let's see. I've got to subtract tangent squared. I'm going to get the secants and tangents on the same side. Since this is negative, I'm going to do the opposite. I'm going to add a secant squared x, a secant squared x. And because this goes away, I'm probably going to want to get rid of this cotangent. In fact, I know that I am. So in this same move, I'm going to subtract cotangent squared x, which cancels there. And what I have left is secant squared x minus tangent squared x is equal to cosecant squared x minus cotangent squared x. Well, if you remember, tangent squared x plus 1 is equal to secant squared x. Well, if I subtract this tangent squared x from both sides, I'm left with 1. Well, that's what I have here. Secant squared x minus tangent squared x is equal to 1. So this side is equal to 1. And if you recall, cotangent squared x plus 1 is equal to cosecant squared x. Well, if I go ahead and subtract the cotangent squared x from both sides, that also leaves 1. Well, here we have it. Cosecant squared x subtract cotangent x. Cosecant squared x subtract cotangent 1x. That is equal to 1. So 1 is equal to 1. Check. All right. So now that I've written over all of this stuff, I'm going to go ahead and erase this now. You'll be able to pause that if you don't have that down yet. All right. So tangent x times cosine x is equal to sine x. Well, I'm just going to, one of the tricks of these identities is to use other identities. So we know that tangent x is equal to sine x over cosine x. So that's what we're going to do. I'm going to replace this tangent x with sine x over cosine x times cosine x. Oh, look at the cosine x cancel, leaving sine x is equal to sine x. All right, we're going to come over here. We have 1 over, well, I could rewrite this as 1 over cosine squared x times 1 over sine squared x. And if you recall, secant x is the same as 1 over cosine x, and cosecant x is the same as 1 over sine x. So look at what we have here. We have 1 over cosine squared x. Well, that's the same as secant squared x. 1 over sine x squared is the same as cosecant squared x. And look at these two things. Well, if we had 4 times 5 is equal to 5 times 4, it doesn't matter the order in multiplication. We could rewrite that as 5 times 4 is equal to 5 times 4, which is what we're going to do here. These two being multiplied, it does not impact it if we just rewrite it as cosecant squared x times secant squared x, then they equal each other, and we're done. That's kind of a simple look at how you prove that one side of an equal sign is equal to the other. All right, that's it.